Hello everyone. This is just a demonstration of my motor driver. I'm going to call it, I forgot what I'm going to call it now. There we go. Tim's I2C AI DC motor driver. Basically it's quite intelligent actually. It's for controlling DC motors with a quadrature encoder. Or it will actually just control just a standard motor, but you can also have one with the quadrature encoder on, like that. So it's got a motor and an encoder. This one's got about eight ticks on it, I think. I've got a bit more of a detailed drawing. So basically it's a motor like this with an encoder on the back, which has two sensors, and from them two sensors it will determine the direction and how many times it turns around basically. It also, the driver will also has positions to put physical stops. So you can add a max limit and a minimum limit hard stop, and it can also be programmed with soft stops, so it won't go beyond a certain point. Basically, the motor and the quadrature drive comes to the board, and then you have a separate power supply for the motor, and then from your microcontroller that's controlling something like your robot or whatever it is, whether it's a car or something that you're building with DC motors, is just controlled by an I2C bus. So you just got your I2C and your power cables coming from your microcontroller. In this demonstration I'm just using an Arduino Nano. Basically it's the chip that's on it is just some little tiny, I forgot what they are, I can never remember the full. It's STM 8S103F. When you buy them, buy the little packets like this, well, they're about 60p each, so they're very cheap. So and these boards, I think the board actually worked out about the same as well, about 60p each. So you've got like £1.20 for that, and then there's just a few resistors and MOSFETs to add to it. So basically, I don't think that the whole thing is going to cost more than £3 or £4. So it's quite a cheap motor driver, and the MOSFETs I'm using are rated up to 30 volts, 3 amps. So hopefully it will do that. Actually, this demonstration on this motor, I'm actually running this at 24 volts, and it's now working fine. Had a few mishaps. I will be doing a full instruction once I've got a new board, because I've missed two contacts, hence the two wires on this board, the two yellow wires, is because I missed them out on this first iteration. So basically, well, I've got some sketches. Have a look at this one. So basically what we've got is a microcontroller controlling all the motors, and these can be programmed with, well, it'll the I2C address can go from 0 to 127. In theory we can have 126 motors connected to one microcontroller via I2C, which is what makes it so good, really. So basically all it does is your microcontroller will just send a command, a simple command, something similar to G code, like a G01. A G1 is like a go forward command. A G2 is a G is that it's like a go backwards command, or you could have it clockwise or anti-clockwise. Then you've got position. The position is the amount of ticks from the position is the amount of ticks from the encoder. So depending on what encoder you've got, depends on how far it moves. Basically, I've tried to make it quite universal, so it can be used with many. I'm just having trouble with them connectors again. Every time I touch this board, the cables, there we go, the cables tend to get interrupted. I don't know, the power seems to be, well, I don't reckon much of that board. It's a bit of a cheap perf board, really. Anyway, so where was I? Oh yeah. So you just send a command, so like a G command, and then you send a position. So we can send say 9,950 ticks, and then the S is the speed. So the speed is between 0 and 1,000. It's a pulse width modulation value between 1 and 1,000. So it's so the higher the number, the wider the pulse width, and the lower number, the smaller the pulse width. So if we set that at 800, so and we send that command, that's how far it moves. So that moved it like a quarter of a way, and like I say, a G. So basically that went from the 0 point to like a positive value of 9,950. But say I wanted to send it up to this side from the 0 value, we could use the G2. So the G2 will send it the same amount, but from the opposite direction. There we go. So we can check that that position by sending another command like the X. So if we send that X, basically what that does is it asks the Arduino, it tells the Arduino to get information from the motor driver. So if we send that, it sends and then it gets this information. So we can actually see that we're actually at minus 9955. And that we're actually on I2C address 48, and then we're at a speed of 1k. And then these other ones are special settings that you can actually set in the motor driver to make it do things like we can tell it to have a max position and a min position, and we can either set them on or off. But I'll go into more detail once I do the instructable. So basically what we got, let's find another picture. Yeah, so you know, basically what you can do is you just wire up the one Arduino. You've got an I2C bus, and then you just connect each one onto that I2C bus, and the motor goes to the motor points, the motor power goes to the motor power points, and the quadrature encoder goes to the encoder points. And I've put a little power supply for the encoders there as well. And then you've got the three different trips. These are little micro switches that you can add for a maximum and a minimum, and there's also a station as well, so you can actually set a point to put to a specific value. So I think I did a bit of a flow chart as well. There's a flow chart of it. So basically you've got your Arduino, which you can control by Bluetooth, USB or Wi-Fi, and it comes into your Arduino, and then your Arduino goes to, like I say, each motor driver has its own address. So you could put, in theory, you can put 126 motors, or well, control 126 motors with one Arduino. And so there are other commands I've put in there as well. You can just have your basic commands forward, so if I select that, send that, it'll just keep going forward until it actually stops. And even while the motor's moving, you can send the X. So if we send the X to find out what position it is, that's the position it was. Send it again, and so we can do it live. So you can keep watching the actual position and keep getting the information while it's actually running. And then we can just actually send a stop command. If I just press the F, and that'll stop it. And then obviously we can see what position we're set at. So send an X again and get that information, and we can see we're at 65,200. So if I now send, it still knows its position, so you can still tell it to go to another position. So we can, I'll just put 995 in there. Well, no, that's just, well, I might as well bring it back to 0, aren't I? And then we can actually, in theory, it should come back to that point really, but just see what position we're at. So if we send the X again, we can see we're currently at 6559. Send again, we're at 23933, and there we are. Well, we've actually reached the 0. We'll come back. It wasn't right on the spot originally, it was a bit off. So hopefully I'm sure people who build robots and things using lots of motors may find that of interest, and if you've watched it right to the end, thank you for watching.